the other system that we started with, and we graphed this, and we found that this graph gave us the same line. Each equation gave us the same line. The lines coincided, so we had infinitely many solutions. How could that happen? Okay, well, let's see what this process gives us. Okay, I've written these equations here in augmented matrix form. I want to get a 1 here. How do I do that? I take half of the first row. Half of 2 is 1. So I've also got to do half of 3 and half of 6. So I get 3 halves and 3. And I leave this row alone. Okay, next, what do I do? Well, I want to get a 0 here. And I want to keep my 1 here, which means I'm not going to mess with my first equation. I'm going to mess with the second equation. So what I do the second equation. Well, I do -4 times the first equation to get a -4 there, and add it to the second equation. So I do -4 times the first plus the second. I'm going to write that out. -4 times the first is going to be -4, because -4 times 1 is -4. And -4 times 3 halves is -6. And -4 times 3 is -12. That's -4 times my first row. And then my second row is 4, 6, 12. And when I add them up, what do I get? I get 0, 0, 0. Okay, well, in the process of trying to get a 0 here, I got 0 here and 0 here. So now, what does my system reduce to? The system has become the equivalent system. Because every operation I did had no effect, no operation that I did had any effect on the solution. Okay, every operation I did gave me a system with equivalent solutions, with the equivalent systems where the solutions are exactly the same. And now the system is x plus 3 halves y equals 3, and 0 equals 0. Well, there's no information here. Okay, 0 equals 0 doesn't add or take away anything from what we get on this solution. Unlike over here where we got 0 equals 6, that was information. That told us that the system is inconsistent. It told us that if the system is consistent, an equivalent system says that 0 equals 6. Well, that's untrue. So the whole system is untrue. The whole system has no solution. In this case, the system has a solution. Matter of fact, it has many solutions. Okay, pick any x. Let's go ahead and pick any y. It doesn't matter which you pick. Pick any y, you can solve the first equation for x. Now, there are infinitely many possible choices for y because there are infinitely many real numbers. So there are infinitely many choices for y. So there are infinitely many solutions. It's kind of important to understand that. But whether you completely understand that or not, our main task here is learning to row reduce matrices.